rectangular to polar equations conversions. Then, before to do some examples to explain how to do the conversions from rectangular form to polar form, I need to remember the important equations. You can use it to do the conversions. You need to use arc x is equal r cosine theta, y is equal r sine theta, and x squared plus y squared is equal r squared. Using these three expressions, you can do the conversions from rectangular to polar. We have now the first example, y equal 2x minus 1. Then you substitute y by the expression r sine theta, and x you substitute by r cosine theta. This is this expression, and this one here is this expression. You change the value of the y by r sine theta, and you change the value of the x by r cosine theta. And the problem now is solve equation for r. Then, to solve the equation for r, I need to move this term to the left side. Using inverse operations, you're gonna have this adding, when you move here is subtracting. After that, you find the common factor is r. You have r and r here. R is the common factor. And after that, you divide everything by this expression. And when you divide, you have r equal -1 sine of theta to cosine of theta. This is the representations of the line y equal to x minus 1 in the polar coordinate system. We're going to do now an example of this. My first function, f1. We find this one. Now let me add now here another functions. The line I'm going to use now, it is the expression, the line in my example is 2x minus 1. Now y equal 2x minus 1. And this is the line. This is the green line. Y equal to x minus 1. -1 is the y-intercept, and 2 is the slope. From this point, you move 1, 2, and a 1 to the right, and you connect the point, and you have the graph. Now, find it now in the polar coordinate system. I'm going to change this. It's blue. I don't see, because if you remove this one, I have blue. You see the representation of the line 2x minus 1 in polar coordinate system is this expression. 2 equal -1 over sine of theta minus 2 cosine of theta. Now, using the polar coordinate system, you see it's the same, and I remove here, it's the same graph. Okay? Now we come back now to continue to another example. Another example now. And here, example number 2, y equal 5. You change the y by r sine of theta. You divide by sine to solve for r. And this is the graph. Y equal 5 is the horizontal line with the y-intercept is 5. We're going to say the graph. It's a function number 2. I have here, going to add now the function y equal 5 is this one. Y equal 5 is the function. This is the point 5. Now, using the polar coordinate system, using the convention, we find this one. When you activate it here, you see, it's the same graph. The same graph. Okay, the same graph. Okay, now we're going to do another example. Example number 3. X equals -4. It's a horizontal line. You change the x by r cosine of theta. You divide by cosine to solve the equation for r, and it is -4 cosine of theta. We go now to the graph. It's example number 3. This is the function. Could the x-axis, let me, this one, no, this one, here, the x-axis in negative. The x-axis now is, you go to example, is x equals -4, and this is the equation for x equals -4, and now, you see, let me change the color here. You see, this is the line. You want to change the color here. I'm gonna here. I want to get red, and done. And I have my line, and cut is a vertical line, and cut the x-axis in -4. This is my equations. This is a vertical line passed through the point -4, 0. Next, y squared equal 4x as a relation. You do the same. You substitute y by r sine of theta and x by r cosine of theta. You solve it. This is the product of power. You have product to the power. Using the property is r squared times sine squared. And now, remember, I need to solve for r. I move for r cosine of theta, move to the left side. Common factor is r, and I have two equations, two solutions. R equals 0, so this is r equals 0, or all this expression equals 0. R equals 0, or all this expression is equal to 0. Select the second equation, and I'm going to solve for r. You move 4 cosine of theta to the right side. This is subtracting. When you move to another side, is positive. Adding. You divide by sine squared to leave r alone to solve for r. And now, sine squared in the denominator, sine squared here is sine times sine. But if you remember, cosine divided by sine is cotangent. And a 1 divided by sine is cosecant. Now, this is my equation. Without going now to my graph, go to my graph here. This is my function. That is the relation. Okay? This is a graph corresponding to y squared for x. But in this case, it's in polar coordinate system. Okay, we come back now to another example. Next example. My example now is x squared plus y squared equal 4x plus a y. You substitute rx squared plus y squared is here r squared. I change this by r squared. You change the x by r cosine of theta. You change the y by r sine of theta. You divide by r. You divide by r squared. Divide by r is r. When you divide by r here, you divide by r. You divide by r. You divide by r everything. You divide by r everything. You cancel this, one of this, you get an r. You cancel this with this, and you don't have r. You cancel this with this, and you don't have r. And this is the equation. Okay? What graph is this one? We go now to my graph. It's a function number 5. Function number 5. It is the circle, and the center is 2. Center, this is the center. 4, 2, 4. Now, this is the circle. This is the equation of the circle with center 2, 4, okay? And the radio, we need to find the radio. But you can use it to find the radio. You can solve this one and change this is in general expression to standard form, and you find the radio. But now the topic today is change, do the conversion from rectangular to polar. Another example. You see, this is hyperbola. Remember, this is the hyperbola. I want to remove the denominator. To remove the denominator, I'm going to multiply by 36 because it's a lowest common multiple. This is the LCM of 4 and 9. When you multiply by 36 everything, you have 36 divided by 4 is 9, and 36 multiplied divided by 9 is 4. You have this one. Now you change the x and you change the y by the corresponding expression. You change it. R is common factor. R squared is common factor. You divide now everything by this expression. You divide to leave R alone. And now to remove the square, what do you have to do? Square root. A square root, you need to find a square root of everything. And the square root 36 is 6. And the square root of the denominator is this one. And I'm going now to represent graphically this polar function. It's an example number 6. This one. You see? It's the hyperbola. The same hyperbola. Okay? Now we're going now to do the last example. The last example. Okay. I prefer to do all of this because I want to explain this step by step. Remember, you need to use this one. You need to use this expression. And you need to use this expression. Now, my example is these rectangular relations. What you have to do, you say x squared, you keep x squared. Now you expand this binomial using this binomial expression, because this is a perfect square, and you say the first square, 2 times a and b, you say 2 times 3, 6 times y, 6y, and 3, that is the second term here, 3 squared, and this is 9. And now, x squared plus y squared is r squared. And you change the y by r sine theta. 3 squared is 9. Equal 25. You move 6 to the other side, subtracting. 25 minus 9 is 16. I'm going to change now. You change now this expression as a b. Okay? You have this quadratic equation. The quadratic equation. Now, I consider c is equal 16. 6 is equal 16. Okay? And b is 6 sine theta. And I have now the quadratic equation. How to solve the quadratic equation? This is the expression. If you want to see how to solve the quadratic equation very fast, in my channel, find the video Perfect Square Faster, Solve Quadratic Equation Faster. In this video, I explain the faster method to solve a quadratic equation, and I use these expressions. Now b is 6 sine theta, it's here, divide by 2, c is 16, and all this expression is all of this one, 2 square, okay? Now 6 divided by 2 is negative 3, negative 6 divided by 2 is negative 3, plus and minus 16, negative 6 divided by 2 is 3, But a square is 9. When you divide 6 and negative 6 and 2 is negative 3. But negative 3 to square is 9. And a sine square of 0. And I have this equation. How to make graphically this? What representation of graphically? Is this one? We go now here. Okay, and this is the, let me move here. You see? This is the ellipses. This is the ellipsis. See what happens if I change this number? Oh, it's changed. Nah, I'll do this one because I want to show you a beautiful graph. We can use it polar coordinate system. In the next class, in the next video, I'm going to show you how to represent very beautiful graph using polar coordinate system. I'm moving back here. I'm going to be 3. Thank you very much to watch this video, and I will see you next time. Bye bye.